as part of this basic SQLs, so it is good to know, like before going to DBA training, if you are good to know this, what are all the basic SQL commands which we are using as part of our DBA job. So why we need to use these basic SQLs? Why? Because if you want to interact or communicate with your database, we need to communicate with any one of that language. Okay. Generally, we used to have different languages, right? Java language and Python or some other languages also. We have a structured query language is the language which is understand the Oracle database. If you want to speak or if you want to communicate with Oracle databases, it will understand with SQL and PLSQL language only. Okay. In that SQL language, what are all the commands we are going to use or perform as part of DBA operations? We are going to use DDL, DML, DCL, TCL, and DQL. I'll tell you in a couple of seconds what are all the complete abbreviation for DDL and DMLs. Okay, this is the main picture, guys. DDL, DML, TCL, TQL, and DCL. So as part of DDL, data definition language. DDL means data definition language. So create, drop, alter, truncate. If you want to perform any create operation, drop operation, alter operation, or truncate operation, we have these operations, we call it as DDL operations. And data manipulation language. If you want to insert data to the database, we can use insert operation. If you want to modify existing information inside your database, we need to use update operation, update command. If you want to delete the information which is there in the existing database, you can use delete option. Call, explain, call, or lock. This mostly we are not using that. Okay, but it is good to know sometime, right? If you are using explain, call option or lock option, we should not be in surprise mode. Okay, but we used to use regularly insert, update, delete operations. Okay, and the TCL, this is a control transaction or the controlling languages, commit, save point, rollback, and other operations. DQL, data query language. This is a read-only format, or if you want to read the data from the database, you have to have use DQL. And DCL, data controlling language. Even if you are able to insert the data, or you want to update the data or delete the data, if you want to create the data or drop the data, you want to perform or select the data. If you want to perform DDL, DML, and DQL things, you have to have to provide these privileges, grant privilege. Without this grant privilege, we cannot use, our user cannot use, our application cannot use these operations. So DCL is the controlling language. So if after, once you have granted this privilege, any one of that privilege, create, insert, update, delete privileges to that any particular application or database user, after some time, if it is not required, we need to roll back it. If we want to revoke it, how we are going to use that? By using revoke operation, a revoke command. We have to revoke the privilege from that user account or user. By using this revoke, we can revoke the create operation or insert operation, delete operation, and update operation, and so on. So these are all the basic commands. That is fine if you learn these things. Okay, we gone through this, right? Data definition language. So this create, drop, alter, truncate, commit, comment, and rename, these are all by default, it's a committed one. You don't need to once you create user username identified by the password, no need to commit it. That is already committed. Okay, all DDL commands are by default committed commands. And next one, DQL, data query language. DQL is for the select operation. If you want to read anything, we have to provide the privilege, select privilege to that user account, then only they can able to select it. If you are simply creating the user or account, it will not connect to the database until unless we are providing the select privilege. Connecting is different. Connection resource, one privilege will be there. That is a basic privilege. Okay, but if the user wants to read the data from the database, we have to provide the select privilege. Okay, what the select privilege is doing? Retrieving the data from the database. If you are not providing this select privilege to that user account or application account, there is no meaning, like without providing the select privilege, what they are going to do it. So basic privilege which we are providing is connect and also resource privileges, and then select privilege also we are going to provide. Data manipulation language. These are like we are going to provide on non-productions most of the users insert, update, delete privileges. On production, most of the users or applications we are going to provide only DQL privilege, only select privilege and production we are giving. As a DBA, we are holding everything, insert, update, delete. We are the admins, we are holding all the privileges, but we have to restrict the users. We should not provide the DML operations or DML commands or privileges to any one of that user until unless they have proper approvals. Okay. So if you are providing the update one, means anyone can able to modify the existing data in the production. So we have to restrict this update. Only restricted users we are going to provide. Any one of that. If we are providing the insert, that is fine. But even this is also, these all DML commands are very dangerous commands. On non-productions, okay, we are even in the non-production also dev environment, we have to provide these privileges. Why? Because if the developer team, they want to develop something or they want to modify some information in the existing tables, if they want to do some fix-ups, okay, issue fix-ups or data corruption issue fix-ups and all, they have to have the read-write access. Read means only select privilege. Write means they want to write something, they want to existing data modification and all, right? We have to give insert, update, delete and other privileges as well. But in production, we have to restrict them. We should not provide all these privileges. Only select privilege we are going to provide. But if somebody is required some other, there could be a senior developers, there could be a senior application team members. From them, for those guys, we will provide with the approvals. Okay, and DCL mostly we are holding as a DBA, we are holding this DCL, data controlling language privilege granting. Why? Because we are only the one admin guy in the database to create a users, providing the grants, providing the DML commands and DDL things. And also if somebody wants any specific privileges, those we are only one who's going to provide these privileges. And if somebody doesn't need, or if somebody is leaving the organization, we have to revoke the access, we have to remove that account from the database. That also we are going to provide. Okay, as and when they are joining to the company, we are going to provide the access. As and when they are leaving the company or that account, we have to revoke the accesses. We have to delete or revoke the privileges. Okay, that is the case where we are going to use the revoke privilege. See, the syntax is this one only. We will see this as part of user management, how we are going to provide the privileges and how we are going to revoke the privileges. Also, what is privilege and all we will discuss as part of user management. Transaction control language. Okay, these are we are not going to provide to anyone. It's as part of transactions, right? If you are going to update some information, immediately you have to use the commit option. Okay, if you are not doing this commit for DML, data manipulation, language related. After you inserted the data, if you are not doing the commit, that will not store it. If you close the session, the data will not be stored in your database. If you did the update command, okay, if you are not enter the commit after update, the data will not be stored. That will be in a buffer until unless you commit it. That will be till that commit executed. Till that point, the data will be in a buffer. Buffer means a temporary storage. Okay. If you did the commit, it will go to your database, original data files. It will write it. Okay. By mistakenly, you did wrong transaction update. Instead of 100, one employee salary is 100. You are going to increase to 200 instead of 150. Okay. You just updated to 100, but you did not given commit option. So what will happen if you did the rollback? The transaction will be rolled back. But if you did the commit, it will store in your database. Later on, if you want to modify, again you need to update it and then you can commit it again. That is fine. But without commit, you want to roll back, you can roll back the information. It will roll back it from the cache. Okay. Or if you are doing some packages or objects, you are going to compile it. Okay, you are seeing some errors in the objects. The object is not compiled. Compiling means if it is a new object that needs to be updated in your database, we need to do that compilation. Okay, the compilation level, if you are seeing some errors, you can roll back it. And then you can ask developers to modify that errors or fix those errors. Then they will give you the new object. That new object, you can recompile it. Okay, if there is no issues, you can do it commit. If any issues happen while you are doing that compile operations and all, you can roll back it. Okay, save points and all this different scenario as and when you are going to perform the migrations or any critical operations on your database. If you want to save, create a save point, it will do the save point for all the transactions, committed transactions. Okay, these are all the basic SQLs which we want to know. Like we have to know, not we want to know, we have to know before starting DBA training. Okay, as part of DBA training, somebody will ask us to provide read-only access. Some accountants or some developers, some application users or some application accounts, they're asking read-write access. What is read-write access? What is read-only access? Read-only means we are going to provide only select privilege to that users. If they are asking read-write means we have to provide select operation, insert, update, delete operations as well. Okay. That's all about our basic things before going to the DBA training. Next, we are going to learn about Oracle 19c architecture part. And also I'll go through that quickly. What are all the course index we are going to cover as part of this training. Now coming to our architecture part, till now what we learned is we have gone through the roles and responsibilities, course index, we gone through it, and basic Linux commands, SQL commands, everything is covered, right? Now we are going to learn Oracle 19c architecture. This course is delivered in 19c itself. Okay, in 19c architecture, even Oracle has introduced in 1970s itself. 1917, they started their databases support and all. Later on, they are improving more, and then they are developing new features, adding new functionalities. Then they started with Oracle 7, 8, 8i, then 9, 9i, then 10G. 1 second. Okay, 8i. From 8i onwards, internet, I means internet. It famous. Oracle database has been famous. And then 9i. 9i RAC has been introduced, and 10G. G means grid infrastructure. Okay, grid. Then 11G. 12C database. Then 19C database. 21C and 23C. These are yet to release the primary releases. Production release, development versions, these two are released, 21C, 23C. 19C is a long-term support. We are going to learn the training, DBA training from this one. C means cloud, G means grid, I means internet. Okay. From 12C onwards itself, they have given multi-tenant functionality. Multi-tenant, we'll talk about in few slides, like in few seconds, we will talk about what is multi-tenant and non-multi-tenant. But these are all the versions, guys. From 11G release to onwards, the scan functionality has been introduced. 11G release to 11G version. Release 1, we don't have much functionalities, but yeah, they have introduced a lot of new features. But 11G release 2 onwards, we have scan functionality in track, single client access name. Okay, as part of architecture of rack and all, we will discuss clearly what is the use of scan functionality. Okay, and 12C, even in 11G release 2, we have some other extra functionalities also. If you are an apps DBA, there is some EBR, edition based redefinition. One new functionality they have released. This is something new to enabling the online patching and all. This functionality they have introduced in 11G release 2 only, but we are using as an apps DBA, we are using from 19C only, this EBR functionality. Okay, not only 19C, but this thing, EBS version R12 to one thing is there. From that version, we are using this EBR functionality. That is out of scope. Leave it, guys. Okay, in 11G, as I said, like number of changes, drastically changed. Grid infrastructure has been introduced. Grid infrastructure. Till that 11G release 2, we have grid architecture. There is no complete ASM binaries we need to install separately till 11G release 1 and all. Separately we need to download and all. But 11G release 2 onwards, we have completely the ASM binaries also included with that database binaries. Okay, grid binaries. So that we call it as a grid infrastructure. So drastically changes from 11G release 2 in Oracle side as part of real application cluster and all. Okay. And 19C, it's a huge auto upgrades. From 19C version, they're given the future auto upgrade. If you want to do the upgrade database from 11G to 19C, you can do by using auto upgrade utility. And also DBUA is there, database upgrade utility concept, that also we can use. And also manual upgrade also will be there. So we talk about this concept, what is manual upgrade, what is DBUA, what is auto upgrade. These are all the ways, different ways to do. You can upgrade your version from lower version to higher versions. If you want to upgrade from 11G to 12C, 12C to 19C, 19C to 21C or 23C, here we have, even in 21C, we have huge changes. In 21C, we don't have a DBUA utility. Database upgrade assistance will not work on 21C. Okay, auto upgrades, we can do that. Or else pluggable level database upgrades. One pluggable, you can unplug and plug it. And then there you can upgrade it. That is also very useful, and very fastly we can upgrade our databases compared to these previous versions. Okay, those many changes are there. Okay, so that is the history, guys. Okay, Oracle database introduced in around 1970s itself. Later on, that is improved every couple of years, 2 years once, 3 years once. They released new versions. From 8A version, Oracle has been famous, and then keep on their growth like anything, #1 in the market. Okay, latest version is 19C. It is going to support till to at least next down the line 8 to 9 years. Okay, 2032 till that time. Support means we discussed it, right? If any issues happen, we are able to raise an SR. Oracle team will support us. Okay. We will talk about, we are having two types of architectures. One is non-multi-tenant and multi-tenant architectures. Non-multi-tenant architecture or non CDB, both are same. Non CDB means container databases. In multi-tenant, we are using container databases. But non-multi-tenant, we don't have a container database concepts, standalone, normal database architecture. This is the architecture. We used to have one database, CRD files will be there, and one instance will be there. This combination we call it as normal architecture. But in case of multi-tenant architecture, we'll talk about these things. Okay, as part of this architecture itself, we will go through it clearly. I'll tell you one thing. Yeah, as part of this architecture, we'll go through one by one. What is Oracle instance? Inside of that instance, what is SGA, and what are all the background processes, and then what is database storage, or what is the database, what is mean by the database. Okay, we gone through it. What database means, it's a collection of related information, but architecture wise how it will be. Okay, database is holds all the physical files, and instance is holding all the logical system. Okay, when you're going to start up or shut down the database, we call it as a shutdown database, startup database, right? We are not going to shut down and start up of this part. We are going to shut down and start up this part. If it is up and running only, we are able to access this. If it is down means we cannot access this. If it is up means we can able to access this database. That is where we are going to shut down and start up Oracle instance only. We are not going to shut down and start up database, because there is no concept to shut down and start up on this part. Then multi-tenant architecture, guys. Multi-tenant architecture, it will enable you to access multiple databases in single server. Not the single server, single database software. You can install one time the software, one software. On top of that, you can install your multi-tenant database software. Then you can configure multiple databases. Okay, earlier how it could be. Earlier, it's a non-multi-tenant, right? Here, what we are doing is one server. This is one server. If you want to install one database on one server, we have to have operating system. That is clear, right? Operating system on the server. This is node 1. On top of this operating system, we have to have install database software. If I want to install multiple databases, okay, I can part it. So on this server, if I want to install 4 databases, 1, 2, 3, 4 databases, I need to install this software one time here, 2 times, 3 times, and 4 times. So 4 times I need to install the database servers. This I can install U01 mount point and U02 mount point, U02. Single mount point we cannot install multiple database softwares. Even that is possible, I think, but we have to use different directory structure. Okay, that is different scenario. Leave it that part. U04. So different mount points and a single server. I need to install multiple times this software. Okay, but in case of why we need to install it multiple times, why we need to use this multiple times, right? If you are having 4 applications, different applications, apps, 4 application servers, all 4 needs to be different businesses for this client. 4 applications is needed, 4 databases. So you need to install 4 different databases on single server, or you can take another server, their operating system, and you can install database software, DB software. And you have 4 application servers which need to be connected to one it here, another one is here. And this application related task will store. This application is need a database. Why? Because whatever the data is generated here, the data should be stored in a database only. It won't store in other ways. It requires a database. And one more server, operating system install, database software install. You can use this database. This also you can use this one. So single server, 2 application databases. Load will be there. For 2 applications are accessing single server, and also performance issue will be there. You need to improve the lot of the settings and all other things. But if you are using, also maintenance is also difficult. If you want to apply the patch on this home, we need to shut down this complete server, and then we need to shut down, or else you need to shut down these 4 databases. Individually also we need to do it. All the homes, 4 times we need to apply the patch if you want to apply this kind of environment. Here also, if you want to apply 1 time here, 1 time here, we need to apply the patch. So the maintenance will be the difficult part as part of non-multi-tenant architecture. But in case of multi-tenant, right, single server, operating system we installed, multi-tenant CDB we configured. On top of the CDB, you can create 0 or 1 or n number of PDBs. Each PDB, we call it as one database. If you are having different applications, 5 application servers is there. All these 5 application servers are connecting to this one application, this one application, and this will connect to one application, and this one. This one, if you want to connect another application, that we can connect it. So to maintain, if you want to do some patching operations, only the CDB level we are going to apply the patch. One time patch we are going to apply for all the 6 databases. But in case of here, this is different Oracle home, this is different Oracle home, different Oracle home, different. All these 4 Oracle homes we need to apply patch in 4 times. This is simple scenario. If you are having, the customer is having hundreds of databases, how we are going to do? 100 times the same patch we are going to apply. In case of this, you can configure hundreds of pluggable databases on one single CDB. If you want to apply a patch to hundreds of databases, one time if you apply this as a patch, that is fine. How much drastically change it, right? Also, if you want to do the clone, we have to do it this home clone or the database clone. We need to do it a new server. That will take time also. We need to take the backups and all. We need to do the copy portion, network portion, and then we need to restore over there. Lot of things will be there. But in case of this multi-tenant architecture, you can unplug this, or you can take the backup of this pluggable database. Simply you can one more server. It's a non-production server, operating system, CDB, and pluggable. Here you can create a pluggable database in minutes, or in case of your database is used, in hours we can complete it. Okay, if you don't want this, you want to move this pluggable database to another server. Earlier, if you want to migrate the database from one server to another server, it is huge activity. But in case of multi-tenant, it is very easy activity. You can unplug it here, copy the data to new server, there you can plug it. That's it. Very simple. 3 to 4 steps we can complete it. So resource wise, DBA resources are required more resources. If you are using 100 servers, okay, 100 servers, if you want to apply the patch in 3 hours in each server, 100 into 3, how many hours we require? 300, right? 300 hours is required to apply complete patch cycle. Non-multi-tenant. The same case, if you are having 100 databases in one server in a pluggable manner, 3 hours we can complete it. It may take some extra time, not only in 3 hours, it may take 10 hours. Compared to 300 hours, within 10 hours we are going to complete that activity. Hugely we can save, right? Earlier, I mean, in this server, we have one more thing also there, that is resource. Each server you are going to configure, you are going to use the memory, CPU, IO. Whatever you are going to use it, buffer will be there. Every server, 10 to 15% of the buffer place will be, I mean, space or requirement will be there. That is useless. Like, it is a buffer only. We are not using at all. If you are maintaining such kind of servers, 100 servers, 100 into 10, 1000, right? So 1000% of your 1000 means you can take 1000 GB generally. 1000 GB of your memory waste means it's a huge cost to the client. Resource wastage will be there in non-multi-tenant. But we don't have that functionality, right? Oracle introduced recently in 12C onward, they introduced multi-tenant, but 19C, most of them are using. This is a best flexibility, right? So resource-wise, DBS are earlier we required more DBS, but here less resource of the DB resource we can utilize, and server resources less. I mean, if you are using 100 GB of memory, in case of here 10 GB, 10 servers you are maintaining, okay? 10 GB, 10 GB, 10 GB, 10 GB. So each 10 GB you are going to waste or buffer 10 to 15%. Okay, almost 10 to 15 GB buffer you are wasting here. Here, if you want to maintain same 10, I mean, instead of going for the 10%, less percentage we are going to utilize the resource. Wastage will be huge here. So that is the best benefit if you are using multi-tenant architecture. This is non-multi-tenant architecture, and I'll show you the diagram in a couple of slides. In multi-tenant architecture, we are using CDB and PDB mode. CDB means container database. It holds your database binaries or software related information. Okay, without this PDB also you can create container database and you can use that as well. There is no restrictions, right? CDB includes 0 or 1 or many, 0, 1 or many customer created pluggable database. What is pluggable database? Pluggable means if you want, you can plug it or unplug it. Means the database, if you are using different application, each application is required one database. That database we call it as one pluggable database. Okay. It's a portable collection of schema objects and non-schema objects. Everything, all the objects which are related to that specific business, we call it as a pluggable database. Each business, if you want to create a database, you can create a database like a PDB1, PDB2, PDB3, and so on. In 12C, we are using up to 256 pluggable, 250 plus pluggable, 250, I think around 250 pluggable databases in a single container. But in 19C, it's a huge, thousands of pluggable databases you can maintain. Okay, that is one difference, 12C and 19C. Okay, all Oracle database before 12C were non-CDBs. 12C database, even in the 12C and 19C, without pluggable and CDB databases, we can use, without this multi-tenant architecture, CDB, PDB model, we can use it. But from 21C onwards, we don't have any non-multi-tenant. Without CDB and PDB, we should not use. There is no option at all in 21C. Okay, till 19C, we can use CDB PDB model optionally. If you want to CDB PDB, you can use it. But before 12C, we don't have this kind of multi-tenant architecture and all. In 11G release 2 and all, we don't have these multi-tenant architectures. Okay, in completely in a CDB wise, okay, high level definitions of the CDB. Okay, a common user like in a database. If you want to store in a CDB level, what are all the files is going to store in CDB? Let me make it this bigger or closer. Okay. This CDB holds control files, redo log files. Okay. And CDB seed will be there, and these are all the PDB data files. In each PDB is individually system, sysops, and user tables and temp tables will be there. Okay, undo also will be there. But this control files and redo log files extra will maintain in your container database level. Instance will be same, guys. In standalone database also we are maintaining the same kind of instance, but here also we are going to maintain the instance. Instance means SJ plus background processes. That's where, right, where when you are going to apply the patches Oracle Home, this instance level you are going to apply the patches, not in the database level. Okay, this database level we are introducing the CDB root container. We call it as a root container. CDB $root means it's a CDB container. Okay, it includes all CDB root and PDBs also, if any PDBs are there or not in the system. Okay, it's a logical container for this system container or logical container. We call it as a CDB thing. Even in the CDB, okay, in the CDB architecture, this is Oracle instance, that is fine. If you are using in a CDB, it is an instance. Okay, if you are using CDB, this is a database. Using CDB means inside of the CDB, it's a CDB $root. It's a container. Okay. If you want to use individual pluggable databases directly, we can create it. But if you want to install or configure this application container, On top of this application container, this container it holds n number of pluggable databases. Okay, this is the parent CDB, but in the CDB we are going to create application container. On application container, we can use pluggable database. This is PDB seed, this is PDB1. Application, PDB2, PDB3. In this way also we can do it. But I haven't seen much this kind of architecture anymore in my till now. But some organizations, they may use application container also. This is CDB root architecture. This holds one pluggable like PDB seed. It could be read-only mode, and remaining are the pluggable databases. This architecture we are going to discuss, not this one. But for your information, we should use this kind of architectures also as part of multi-tenant architecture. We are using this one PDB seed, one CDB. Any server, one CDB only will be there. There is no more CDBs and all. On top of these CDBs, we are using 0 or 1 or multiple pluggable databases we can maintain. These pluggable databases only we can use for application connectivity. So application, BI applications, EBS applications. For EBS case, we mean this only one restriction is there. Single PDB should be there. It won't support multiple pluggable databases for e-business suite. But other SOA and other applications, you can use multiple pluggable databases. That is only one restriction. Okay, this architecture we are going, this is instance SGA plus background processes. We'll talk about this each individually. Okay, so what are all the information which holds in CDB? CDB holds your system, sysops, undo, temp, control files, redo log files. All these files will be held. Remaining pluggable database, each pluggable database is holds system, sysops, undo, and temp user table spaces. Temp also it should maintain its own. But control files, redo log files, these files are maintained only in CDB level. Okay, that is where it is restricted other pluggable databases. Okay, then as I said, right, with no application, the same architecture. This one is with application container, without application container. We are learning without application container. Okay, application container is nothing but if you are using some application, it's a PDB seed, right? CDB, it's a main architecture. Complete CDB, we are using root is CDB root only. Inside of that, if you are using CD sales application, HR applications, this okay. This is architecture which we are going to do practice in our labs, in our DBA session. Okay, this is without application, no application. Directly we are using PDB seed. This one is there. HR pluggable database, sales, HR related information, everything stored in this pluggable database. We call it as a HR pluggable database. This is the sales. It could be some other applications we can use. This architecture. Okay, we can use 5 containers. One is CDB root, CDB PED, complete CDB thing, and HR PDB, sales PDB. Whatever the users which we are going to create in CDB level, those users we call it as a common users. What are all the users we are going to create on pluggable level, those users we call it as a local user. That we will more speak on user management level. Okay, practically we will see that. This is without application, no application container architecture. But with application container, see here, we have the CDB. Inside of the CDB, we have pluggable PDB seed is there and PDB is there, HR PDB. For other pluggable databases, we created one more application root, application container. This is database container, CDB root. This is application container. On top of this, we created one more container, that is application root container. On this container, we are creating another pluggable databases. Application seed. Here also we have one seed. Also we have 2 pluggable databases. In this way also we can create it. It is parent to child relationship kind of one. But I haven't seen this kind of architecture till now. Some of the organizations, they may use this, but this is the architecture where we are using CDB architecture and multiple pluggable databases. Okay. In this way also we can configure. For your information, I'm showing this. Okay. Challenges, we already talked about that. I'll explain you briefly. So earlier, non-multi-tenant architecture, this is each database server. Each application should connect with single database. So this is configured on one server. So here we are having 11 database servers. So 11 database servers we configured 11 times. So here we required 4 DBAs, one manager kind of one. So 5 DBAs required to maintain all these 11 databases. But in case of pluggable databases, we don't need these many DBAs. 1 or 2 DBAs can manage all these things. Why? Because we are maintaining these pluggable databases in a single container. If you apply the patch and container, that is sufficient. Okay. Resources also very wastage as part of this non-multi-tenant database architecture. So architecture place multiple databases on each server. Head DB oversees team for 4 DBAs. The same thing. This only 4 DBAs. More than 4 DBAs are required to maintain this. But if it is a case of multi-tenant, we are less resources is required. Storage wise, CPU, memory, those also we can save it. But in case of multi-tenant architecture, see here, single CDB, single time you are installing the software and you are creating 11 pluggable databases, and then 11 pluggable databases attached with 11 applications. Okay, we are maintaining all these applications with 1 or 2 DBAs. Compared to non-multi-tenant architecture, to maintain this multi-tenant architecture very easily. Okay. Use cases of the multi-tenant are cost reductions, easy performance tuning, easy maintenance and monitoring. Okay, we can easily rapid more of the data code and all. If it is movement, if you want to move from one pluggable database to another, we can easily move it. If you want to plug it, unplug it easily. Patches and upgrades, very easy in multi-tenant architecture. Okay. This is the high level, not only high level, complete understanding part of this architecture, guys. Multi-tenant and non-multi-tenant architecture, benefits of the multi-tenant and challenges in non-multi-tenant architecture. And those we gone through it. Then we can go with architecture later part. Okay. In the next session, we are going to discuss individually what is server, and then what is instance and what is database. In instance, what are the components we are having? Then in database, what are all the components we are having? We will discuss clearly. Okay. Thank you.